the next thing that I want to talk about is actually doing the aggregate function. So the aggregate function is going to really be a good workhorse for how we can quickly summarize different groups, and specifically kind of estimate what the probabilities are of some event of interest for a bunch of different groups very quickly. So here's the overall goal. Let's go back to the telecommunications churn data sets. Here we had a column for the customer ID, how long they've been with the company, the phone service, yes or no, and also the column for churn. So one thing I might like to do is, well, if I just treated every customer as a trial, figure out the probability that some random customer is going to end up churning. That would just be the fraction of the rows with churn equals yes that I end up seeing, and I could do this for maybe different groups. Maybe I'd like the proportion of individuals that churned for the people for the different payment methods or the paperless methods. So here's what we're going to use in R. We're going to use the aggregate function, and we need a flat file, so we need to get everything in one file in order for this to work right. Merge, we still might need to do that. That's coming up soon. And once we've got that flat file, what we'll do is run the aggregate function, and we just need to know a few things about how the aggregate function works. How do we set this up? So in general, whenever you want to summarize different groups, you'll be running the aggregate function. The first argument is a formula. Now, if you've fit regression models, if you've made plots in R, this sort of syntax is going to be familiar to you. You have a twiddle, and that's going to separate the two different variables or the two different columns that are going to be involved in the aggregation. The x variable is going to be your grouping variable. So if you want to do something for each method of payment, your x variable would be the name of the grouping variable. On the left-hand side of the twiddle is going to be another column name, and that column is going to contain the values that we're going to use in our calculation that we're using to summarize. So if we wanted to look at the percentage of people that churned for each one of the different payment methods, well, y would be that churn column, because we're going to use the values in that churn column, the yeses and the nos, in order to do that calculation. So x is going to be that grouping variable, y is going to be the column that has the data values you'll use in your computation. You'll say, okay, well, here's the name of my data frame that contains that data, it's that flat file. And then we're going to have some fun, and not just any fun, capital F-U-N. This is where you get to specify what you want to summarize. Do you want the average for each group? Do you want the median, the max, the standard deviation, the percentage of some sort of category? This is what you'll put in to the fun argument. Okay, I think it's best just to go through some examples. So what example do I want to look at here? Let me bring back R. And I want to look at a data set that deals with the Kickstarter campaigns. Mentioned very briefly at the beginning of this video, did a campaign succeed or did it fail? I'm going to read in the Kickstarter data. Now, as that's reading in, the data dictionary and the description of the data is up on the Kaggle website. And so we're going to have a bunch of different bits of information to study what makes a successful campaign, what makes an unsuccessful campaign, etc. So what are we working with? Well, we have data on about 378,000 different campaigns, and we have 14 variables, 14 bits of information. We have some ID, one ID per campaign, the name of that campaign, broadly what category it fit into, and main category as well, like arts, comics, split into like 3D printing, etc. We have the currency of the campaign, the deadline of the campaign, when it was launched, how much was pledged, the status, if it was canceled, if it was failed, etc. Sounds pretty interesting. I definitely want to look at that. And then some other bits of information like the number of backers, the country, and the amount of money that was pledged, and also the goal. All right, so let's, for the sake of illustration, let's compare different main categories of campaigns with how much they eventually raised, the USD underscore pledged. All right, so I'm going to set up an aggregate command. I just need to figure out what goes where. So inside the parentheses, the very first argument is that formula. We got to tell aggregate what's the grouping variable and what column has the information that's going to be used in our calculation. So to the right-hand side of the twiddle, that x needs to be our grouping variable. And if we think about it, what are we trying to do? Well, we're trying to do something for each main category. So I'm going to put main category to the right-hand side of the twiddle. What am I doing for each main category? Well, I'm looking at something regarding the values in USD pledged. So I'll put USD pledged here. I got to say, okay, well, where does this data live? The data equals argument will be kick. That's what I've named the data file. And my capital fund, what I'm going to compute for each group, is just going to be the median. So translating this into English, the way that I would read this is for each unique value of main category, go and calculate the median of the USD pledged. If we run this, that'll print to the screen the medians for each of the 15 different main categories here. All right, well, that's all well and good. It's alphabetized by main category, but what if I quickly wanted to sort this data frame, say on the highest median down to the lowest median? Sorting in R, at least with the base commands, is more tricky than what it really needs to be, but here's how we would do it. Let's go ahead and left arrow the result of running aggregate to some name of our choosing, something that makes sense. So let's call it median.pledged. My convention is all caps for data frames, lowercase names for variables or vectors. And when we do this, that'll go and essentially save the result of running aggregate into this data frame. So if I print out the contents of the data frame to the screen, that's what I had ran and printed to the screen when I just ran aggregate. Okay, so if I wanted to sort this data frame based on the values in USD pledged, here's how this works. And bear with me because, like I was saying, this is more complicated than what it needs to really be. I'm going to put the square brackets in right after the name of the data frame. Now, whenever I put square brackets right after the name of a vector or a data frame, that means that I'm going to start referencing something inside that object. Now, since a data frame contains rows and columns, I'm going to put a comma in between these two square brackets. We know the space to the left of the comma denotes rows of that data frame. The space to the right of the comma denotes the columns. So if I'm going to sort a data frame, I'm essentially reordering the rows. So I'm going to put something to the left of the comma. I'm essentially going to put the order of the rows that I want to see. And so the way that I'll do this is actually use the command order, and I just need to say, well, what do I want to order these rows by? I want to order them by the values that I find in the USD_pledged column. I'll leave to the right-hand side of the comma just blank. I'm not going to do anything with the column, so leaving that blank just says leave it as is. And if I print this to the screen, I see that it was sorted from lowest up to largest. If I wanted to do the reverse, I could add an additional argument for decreasing, say that's equal to true, and now it would go from largest down to smallest. Okay, so I've quickly summarized the different main categories of each of these campaigns. What else might I want to do? Okay, well, we saw that if I looked at the different statuses of the, oops, wrong data frame, kick $. If I looked at the different statuses of these campaigns, we can get some information about what succeeded and what failed. So we actually have 6 levels: canceled, failed, live, still going on, successful, suspended, that's kind of juicy, I want to know the details about that, and then also undefined. So what if I wanted to find the proportion of campaigns in each main category that were successful? Kind of like a Monte Carlo simulation, treat each campaign as a trial, and we'll look to see, well, what fraction of campaigns were successful? What fraction of trials did our event just occur in? And we'll do this for each of the 15 different main categories. Okay, well, let's set that up. Let's go and look to see, I want to see what percent of main category had successful campaigns. Okay, so I'm going to borrow my aggregate function here. I'm just going to make changes. First thing I'm going to focus in on is the twiddle. What needs to go to the right? What needs to go to the left? Now, to the right of the twiddle, that's going to be the name of our grouping variable. So once again, we're doing something for each main category. Main category is our groups. So I'm going to leave main category as is. To the left of the twiddle, that says, okay, give me the column name that you're going to use in your computation. Now, for each main category, we're going to compute the fraction of those campaigns that were successful. What column has that information about whether they are or aren't successful? Well, that is the status column. They're still living in the kick data frame here. I just need to say, well, what kind of fun are we going to have with this column? What is the function that I'm going to use in my computation? Now, here's the tricky thing, is that R doesn't have a function like median or mean that's going to allow us to compute the fraction of values that were successful for each main category immediately. Basically, what we see is that as aggregate is running, it'll see a whole bunch of successful, live, failed, etc. We actually need to write a function kind of on the fly to tell R what to compute. We essentially want to count up the number of campaigns for each of those main categories, look at the number of successful campaigns for each of those categories, and take that ratio. So as an example, what if I were to say, okay, let's take a subset of the Kickstarter campaigns whose main category was food. I'm going to call it data. Little x, that's like a vector here. If I looked at a summary of data, and if I looked at the status, what I find is that there's 6,085 out of a total of, well, how many of these food campaigns were there? 24,602. So I know my answer is 24602. I just need to figure out how R can figure out that value automatically. Okay, well, here's one way I could do that. I could say, well, length which, count up the number of values in the status column that are equal to successful. I say length which, data $ status, double equals successful. That's giving me a count of values that are successful inside that status column. And if I were to look up n row of data, that tells me the number of rows. Or if I just said length of data $ status, that gives me the same value. Now, in that aggregate function, I'm already referring to the status column. So these two things are going to be useful in my computation. Basically, go into that column, count up the number of successfuls, and I want to divide by the just number of values there. So one thing I could do is I could define just a function all on my own, kind of outside this whole aggregate deal here. So I could say, well, maybe frac successful could be a function where I look inside the values of a vector x, and I say, okay, well, let's count up the number of values in x that are equal to successful, and divide by the number of values. If I did that and said, okay, well, let's see what frac successful of data $ status is, there's my 24.7%. So going back to my aggregate function, since now I have defined a function that R knows about that calculates the percentage of values in a vector that are successful, I could just say fun equals frac successful. Boom, I got it. If I go and look at food, well, there's that 24.7%. I can see there's a pretty big variation in the fraction of successful campaigns based on what category they're in. I could sort this to bring to the top what the most successful categories were, bring to the bottom the least successful categories. So that's one way of running the aggregate command. Define your own function for what you actually want to be computed from those values, and then pass that as the fun argument. But here's a cool way of doing it. And one thing that I really like about R is that we can actually define an anonymous function, meaning one that doesn't go into the global environment. You don't have to left arrow it to anything to be anything, kind of on the fly. So what if I did something like this? What if I just said, well, this is how I define that function, frac successful. Why don't I go ahead and just say, well, here's the function that I want to calculate. And just to keep notation consistent, the y's and the x's with how aggregate is set up, y twiddle x, y is the name of the column that we're using in our computation, I'm going to change this from an x to a y here. Remember, the names of the arguments of functions that we write are completely up to us. So this is kind of an arbitrary change, but one that I think adds a bit of clarity into exactly what we're doing. Essentially diving into each level of main category, we're going to call the values of status that we find for that main category as the vector y. What are we going to do with that? Well, we're going to count up the number of elements of y that equal successful. We'll divide by the number of elements of y, and that'll give us our fraction. So if we run this, we get the same values out. Equivalent way of doing it. A little bit faster, I think, than actually writing your own function. Keeps the environment a little bit less cluttered as well. One more way, though, and you might like this one even better. I like this one even better. Aggregate is so powerful that you can actually go and write functions on the left-hand side of the twiddle. So what do I mean by that? Well, for each value of main category, normally we've been putting column names here. What if I did something like this? Status double equal successful. Well, normally when I run a logical condition as a command, I get a bunch of trues and falses out. So if I were to say data $status double equal successful, that goes through each entry in the status column of the data frame name data and prints us out a true or a false, depending on if we found the word successful or the word something else there. And since we know trues are the number 1, false is the number 0, if we did something like mean, I'm going to write this up here, mean data $status double equal successful, this would give us the fraction of values inside this vector, data $status, the status column of data, that equal this value. There's that 24.7%. So if I ask for the average of this logical condition, it's going to accomplish the same thing as the other ways I've been writing this command. It's going to go through and say, okay, for each main category, I'm going to go and look at this, basically the trues and falses that result from comparing the values in successful to, or values in status to the word successful. Ones and zeros, if I take the average, I get the proportion of successful Kickstarter campaigns. So this is great. I'm basically treating my data set kind of like a Monte Carlo simulation. Each campaign is a trial. I want to estimate the probability of success for many, many different groups. And so I just look at the fraction of each campaign that is successful. With some conditions, like we're assuming this is a random sample from Kickstarter campaigns, this should be a pretty good estimate of the probability of success for each one of those campaigns. All right. So let's look at another data set here. And this data set is another one from Kaggle, and it deals with hotel bookings. There's a whole data dictionary that goes on here. This is a really fun data set, about 16 megabytes. And what it does is it anonymously, because it doesn't want to give away any secrets here, goes through a bunch of hotels, a bunch of dates, and it lets us know whether or not the reservation was canceled, if it was successful, and a whole bunch of additional characteristics about those reservations. So I'm going to read in, here's what we're working with. So each row represents a hotel and a reservation at that hotel. We have an is canceled field for whether or not that reservation was canceled or not. We have the lead time. How many days was it before the guest was supposed to show up and the reservation was made? We have information about arrivals. We have information about the stay itself, who was staying at that for the reservation, and a bunch of additional information going on here. Okay, so let's look at this hotel data set. One thing I might be interested in looking at is, say, the average number of adults that are associated with the reservation for each, say, month of the year. We have an arrival date month. It's a categorical variable. So let's see what we can do. I'm going to run the aggregate function. But first, put a little note what I'm trying to do. What is the average number of adults per reservation each month? What is that? All right, so the first thing we put in to aggregate is the formula. To the right of the twiddle, that's our x variable, our grouping variable. And in this case, we just think, okay, well, what is my grouping variable? What do I want to do? Well, I'm doing something for each month, so I'm going to say that this is the arrival date month. To the left of the twiddle, I need to put the column name that contains the values I'm going to use in my computation. And here, I want to know something about the average number of adults, so I'm going to put adults here. Where does this live? Data equals hotel. What function am I applying to this? Well, I'm getting the mean. So for all the Januaries, I'll go scour what values I find in the adults column, and I want the average. Same for February, March, etc. All right, so R true to form. Not the most helpful always. We have the months organized alphabetically. What if we actually wanted to arrange those months in chronological order? Well, you can actually reorder the levels of a categorical variable, but once again, it's not the easiest thing to do in the world. So I did this. I'm going to copy and paste this command and just describe what's going on here. So I'm going to take the values in arrival date month and I'm going to overwrite them. I'm going to left arrow, I'm going to rewrite what those values are. And what am I going to do with them? Well, I'm going to give an ordering to the levels of this categorical variable. So I'm going to use the keyword factor, that function that creates a categorical variable. It's already a factor. Running factor again on it is not going to change that. I'm going to take the values I have now in arrival date month, and I'm going to say, hey, ordered equal true. We're going to give an ordering to them. And specifically, what do I want the ordering to be? Well, I just go and say levels equals, and then give it a vector of how I would like the ordering of those levels to be. So January, February, March, etc. Quickly does that, and you'll notice that it's updated in the preview, the hotel arrival date month. It's now an ordered factor. So if I were to go and say, okay, well, what is the average? Much nicer to look at. January down through December, 1.7, rises up in the summer, and then falls down in the winter. Kind of what you would expect. Okay, well, what about the average number of people? We notice we have an adults, we have a children, and we have babies. So we'd like to know, okay, if we added up the adults, the children, and the babies, what would we get for the average? Here's another really cool thing about the aggregate function. As I was saying before, to the left-hand side of the twiddle, we actually have quite a bit of leeway of what we put there. It doesn't have to be just a column name. When we got the fraction of successful Kickstarter campaigns, we said, all right, double equal successful in quotes. Let's get something about the fraction of the values that were successful. Well, we can still do arithmetic to the left-hand side of the twiddle as well. If we want to know something about the sum of adults plus children plus babies, basically the total number of people associated with that reservation, we can just add those three values directly. And R knows what to do with it. So basically for each arrival date month for January, February, March, etc., go and look what the values were in those three columns, add them together. So for the first reservation, add the number of adults to the number of children to the number of babies. Do the same for the second, the third, the fourth reservations in January, and we're going to get the overall average. So when we do this, we can compare to see what happens. Obviously, the averages go up a little bit, not by much. Most of these reservations are basically with adults. August, we got right at about 2 adults on average, and when we factor in the children and babies, that bumps up by an additional about 0.2 here. So pretty fun. To the left-hand side of the aggregate, we actually have quite a bit of flexibility. And actually, to the right-hand side of the twiddle, we also have some flexibility. And this allows us to not only consider doing something for each member of a group, but we can look at combinations of characteristics, combinations of groups as well. So here's a question I have. What is the average number of, let's say, special requests that these customers are giving for each combination of customer type? We have 4 different customer types in the data. And let's also choose the reserved room type. So maybe there are certain types of customers that have more special requests than others. Maybe some room types have more requests than others as well. So in this case, what we want to do is go through each combination of customer type and reserved room type and look at some stuff. We want to look at the average number of special requests. Now, let me see how often each of these 2 combinations actually appear with each other. Let's get a table of the customer type and the reserved room type. So in this case, we have our 4 types of customers: contract, group, transient, transient party, and a bunch of different room reservation types. Anonymized, keep it a secret, A, B, C, D, E, F, G, H, kind of like the alphabet song, but then you skip a whole bunch and it's like, did you forget what happened to M, N, and O? I don't know. So we see that some of these characteristics are more common than others. H, L, and P are relatively rare. L and P especially very rare. And some combinations we don't even see in the data whatsoever. There are no contract customer types that ever made a reserved room type of L or P. Okay, but let's go through and systematically look at the average for each of these combinations here. So let's set up that aggregate command. First thing I'm going to do is set up the twiddle. So to the right-hand side, I'm going to put my grouping variable. And in all previous examples, this was just the name of one column. So if I wanted to do something for each customer type, it would be twiddle customer type. But in this case, I want to do something for each combination of customer type and reserved room type. So I'm going to add reserved room type to the right-hand side and just separate it by a plus sign. That's all it takes in order to consider all combinations of levels across those 2 categorical variables. All right, so what do I want to look at for each of those combinations? Well, I want to look at the total of special requests. Still living in the data equal hotel data frame, and we're going to get the average. Why not? So when I do this, I get 35 different rows. So for customer type contract, A, group, A, transient party, A, contract B, etc. It's going through systematically all combinations of those 2 different characteristics. Or is it? Now, back when we looked at this table, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different reserved room types, and we had 4 different parties, or 4 different customer types. Fundamental theorem of counting says if I want to know the number of combinations, do the number that the first option has, which is 10, multiply that by the number the second option has, which is 4. I should have got 40 rows out of the result, but I only see 35. So what happened here? Well, by default, when you start looking at combinations of characteristics, R is only going to report back to you combinations that exist in the data. And very often, that makes a lot of sense. We didn't see any contract customers that had L or P type reservations. We didn't see any group customers that had an L reservation. If we didn't see it, why would we bother reporting something back on it? But sometimes we actually do want that. Imagine the case that you're working for the Kroger analytics team and you're looking to see, all right, how effective are the coupons that we're personalizing and sending out to each customer. Maybe you send out 16 different coupons to each customer, and you do this over the course of maybe 5 different campaigns. So in this case, what you'd like to do is for each combination of customer and campaign, keep track of the total number of coupons that were redeemed. Well, if you scour your transactional data set, if a customer never uses that coupon, it's not going to show up there. So in this case, if we did the way that R does it by default, and we aggregated by each combination of campaign and customer ID, we would completely omit those campaigns that the customers just didn't participate in. In this case, we would like to force each combination to appear in the results because not appearing is meaningful. That's a 0. They didn't use any coupons for that campaign. So here's what we can do. Easy enough to do in R. If we want to see all combinations, even if we haven't seen them in the data, we're just going to say drop equals true. False. Drop equals false. There we go. So now we have all 40. Notice we have NAs. R is very helpful here, and it says, hey, I didn't see this in the data. I can't calculate this for you. If we wanted to treat this as a number, like with the Kroger campaign customer example, well, we could save the result of running aggregate to a data frame, and we could say, all right, let's change the values in there. So $, total of special requests, that's our column that contained the average number of special requests. And we can invoke the is.na command to let us know, hey, where are those NAs? True if it's NA, false otherwise. And we can just left arrow that maybe to 0. So now if I were to go back and look, all right, what are my values inside that column? I now have 0s instead of NAs. Sometimes that's a smart thing to do. Other times you want to just have the combinations you see in the data. So I think one more example is good here because there's one thing that we like to summarize groups by that R doesn't have the ability to measure in one command. We'll have to write our own function to do that. And that is to count up the number of unique values that we see for each different group. So what do I mean by that? What if we wanted to look at the number of unique countries, or just number of countries, that appear in the data for each arrival month? So there's a lot of countries in the data, 178 countries represented somewhere. There might be hot months where we have people from a lot of different countries make reservations. Well, how would we set up the aggregate command in this case? So we're going to aggregate, we're going to put a twiddle, and to the right of the twiddle, our grouping variable. We are doing something for each arrival month. So to the right-hand side of the twiddle, that would be our arrival date month. And to the left-hand side of the twiddle, what's the column name that contains the values we're using in our computation? That's going to be country. So that lives in the hotel data set. And the question is, what function do we want to apply to it? Well, in English, it's easy. I'd like to count up the number of different countries for each arrival month. Unfortunately, R doesn't have a command like nUnique. Doesn't exist. Should, but it doesn't. So in this case, if I want to count up the number of unique values, the number of different values of some quantity for each group, I'm going to define that anonymous function length unique. Combine those two, and we'll be good to go. So what do we find? Well, the summer months have more countries relatively represented in the data than countries in December here. So that pretty much covers it. When R knows the name of the function, great, you just get to pass that as the function argument. If it doesn't, you can define it on the fly with the use of an anonymous function, length unique, I think being the most common one. And if we wanted to see the proportion for each category, I think my favorite way is to use the mean function and just have on the left-hand side of the twiddle be some logical condition. So if we wanted to know, say, the fraction of reservation statuses that were canceled, I think it's typoed in the data, just one L with canceled, for each arrival date month, we could run that logical condition on the left-hand side of the twiddle. Now, the one additional tidbit about aggregate that you're going to want to know of when you use this in R is renaming columns. Because when R runs the aggregate function, it literally just uses whatever it sees to the left-hand side of the twiddle and the right-hand side of the twiddle as your column names. So we have arrival date month, which makes sense, and then we have reservation status double equal canceled to the right, a really long, very unwieldy column name. So very often, what I like to do is to rename the columns in order to give them something a little bit more meaningful and readable. And to do that, you need to save the result of running aggregate to a data frame and use the names function. The names function prints out what the column names are of your data frame, and you could left arrow that to a different vector. So if I wanted to rename both of these, I could say, all right, just month and frac canceled, let's say. Name them both in one fell swoop. So now we got month and frac canceled. If you just wanted to change the second column, well, you could do names A, well, second element of that vector, bracket 2, and we could name this, say maybe prob canceled. Just name it something different for illustration here. And then we got that.